Okay, the last lesson, and this is going to be split into two videos, is featuring something called compound inequalities. This is really the only thing that's totally brand new. And I say that because everything else we've done in this chapter has either been a review straight out or just combining something we did back in chapter 2 with the idea of inequalities. So a compound inequality is two inequalities combined into one statement by the use of the words and or. And the fancy word that we're going to see today, but not really use much, is intersection. An intersection is the set of numbers that are solutions to both inequalities in an and compound inequality. Today we're focusing on the and inequalities. Okay. So I'm actually going to rewrite what you see here and do this one twice. So this could be written as x plus 2 is greater than or equal to 4 and x plus 2 is less than or equal to 8. So let's do this. I'm going to do this out twice. Once long way, once short way. You'll like the short way better, I'm sure. Okay, so this is just two inequalities with the word and in between them. And solving them is child's play. They both just involve subtracting 2. So x is greater than or equal to 2. X is less than or equal to 6. Big old and in the middle. Okay, so x is both greater than or equal to 2, and it's less than or equal to 6. It is both greater than or equal to 2. Actually, I'm going to do this with a different color. Let me swap out here. It is both this, greater than or equal to 2, and less than or equal to 6, which is, ignoring that little curly Q, I gave it this. So the question is, when is it both of those things? When is it both greater than or equal to 2 and less than or equal to 6? Because and means you must meet both conditions at the same time. Well, it didn't change color, did it? It did not. Swap colors. There we go. It is both greater than or equal to negative 2 and less than or equal to 6 when it is strictly from 2 to 6. The pink one is the solution here, graphed. Kind of looks like a barbell. What we're going to do is we're going to say, okay, these are the endpoints, 2 and 6, and we are in between them. The only question is going to be, do 2 and 6 get filled in circles or not? And we know how to answer that question at this point. So that's long form. Short form. So over here, and inequalities can be written as one string with two inequality symbols. And they will always look like this, in that it'll be a number, less than, expression, less than, number. The less thans can have the or equal to on them, but they cannot be greater thans. In a compound and inequality, the inequalities, both of them, must point to the left if it's written as a single expression without the word and. To solve this, we take the idea of what you do to one side, you do to the other, and say what you have to do to the middle to get x alone, you must do to both the left and right sides. 4 minus 2, of course, is 2. 8 minus 2 is 6. This shows us x between 2 and 6. So we put 0, 2, and 6. And yes, you still have to have 0 on your number lines. Between 2 and 6 with 2 and 6 included. There we go. You're probably going to like the short form better. I'm only going to do the short form for this guy. So how will we get x by itself? Well, first we would have to subtract 3. So what you do to the middle, you do to the ends. Negative 5 minus 3 is negative 8. Less than or equal to 2x. Less than 9 minus 3 is 6. We're going to have to divide both sides by 2. Or not both sides, all 3 parts. We do it to the middle, we do it to both ends. Negative 8 divided by 2 is negative 4. We are dividing by a positive number, so the inequalities don't get flipped around. 6 divided by 2 is 3. We'll know we've done these okay when the solution looks like this. Smaller number, x, bigger number, and less than signs in between. So we need a number line, we need 0, we need negative 4, and we need 3 on that number line. Negative 4 gets a filled in circle because the inequality on that side has the bar. 3 gets an empty circle because that inequality does not. And barbell them, connect them. That's all we're doing here, guys. Word problem. A water analyst recommends that the pH of a swimming pool be between 7.2 and 7.6, inclusive. Inclusive just means those numbers are included. Write and graph a compound inequality to show, oh, here we go with my iPad acting up, pH levels in this range. Okay. Well, we know 7.2 is the lower limit, 7.6 is the upper limit. They are included. Included means or equal to. So there's our written inequality. X, which I'm just using X because we use X. The pH must be between 7.2 and 7.6. Inclusive means it can be those numbers. Graph it. Easy. Throw down on the number line. They both get filled in. Barbell the middle.